In this tutorial, we're going to go over problem 6.1, number 35 from the textbook or study plan. Of course, it might be a different number depending on what version of the text you're using, and who knows where it's going to show up in your homework. But if you look at the top right corner, you can see it says 6.135. Okay, so let me click on View an Example. So I will go over the example, which will be very similar to the problem. The probability distribution of the random variable x represents the number of hits a baseball player obtained in the game for a 2012 baseball season. So this is a probability distribution. It has a discrete probability distribution because the x values are all particular numbers with no decimals. They either make 0 hits or 1 hit or 2 hits, etc. And there's the probabilities that are associated with that. And then the probability distribution was used with statistical software to simulate 25 repetitions of the experiment, 25 games. The number of hits was recorded. Approximate the mean and standard deviation of the random variable x based on the simulation. So this was created from a simulation. The simulation was repeated by performing 50 repetitions of the experiment. Approximate the mean and standard deviation of the random variable. Compare your results to the theoretical mean and standard deviation. What property is being illustrated? Okay, so it seems pretty complicated, but it's not so bad. You start off with the basic probability distribution, which is up here in this table. And then there are other distributions that you're going to have to find the mean and standard deviation for. And that's what they're talking with the simulation thing. So this top one is a simulation of 25 games, and the bottom one is a simulation of 50 games. So you take this probability distribution they've given you here, and the computer basically pretends that it's going to have 25 games for this particular baseball player, and this is what it randomly comes up with. And then it pretends it's going to have 50 games for this player, and this is what it comes up with. Okay, so let's start off with the beginning. We're supposed to compute the theoretical mean of the random variable x and probably the theoretical standard deviation if my memory serves. Well, this is a probability distribution, so by definition you have the entire population accounted for because probabilities are basically the entire future of all possible probability experiments using this probability model. So you're going to want to find mu and sigma. So what you can do is you can grab your calculator, and let me just make this a little bit smaller, 1 second. There, that way I can see the numbers in the background. I'm going to go to Stat, Edit. I'm going to clear out my old tables because I don't need any of this stuff. I'm on a new problem now. And I'm going to clear L3 as well because I'm going to need it in a minute anyway. All right, so I'm going to go over here to L1, and that's where I'm going to put my x values. So 0, 1, 2, 3, 4, 5. Then I'm going to go to L2 and type in my percentages, my probabilities. Oop, I messed that one up. And there we have it. So now when I want to find the mean of this distribution, I want to go to Stat, Calculate, one variable. Now I don't want to just tell it L1 because that will treat 0, 1, 2, 3, 4, 5 like they're all equally likely. But of course that's not true for a batter. A batter is far more likely to hit, well, this particular batter is more likely to hit 1 hit than hit 5 hits. I mean, 5 hits for a batter is a lot. So we want to tell it L1 is the list, but L2 is the frequency list. We always do this for probability distributions and for weighted means and grouped means back in chapter 3.3, section 3. So I'm going to go down to Calculate. I'm going to press enter, or actually just press enter on the calculate, and it runs it and tells me that the mean is 1.7125. Now, of course, the calculator doesn't know that this is a probability distribution. Calculator always says x bar, but you have to know, no, that's the mu in this case. And down here, you can see that's the sigma. It didn't give us an S because our probabilities all add up to 1, and the definition for S has n minus 1 in the denominator, and 1 take away 1 is 0, and that would be bad. So it only gives us sigma and mu, but you have to know that that top number is mu. So 1.7125 and 1.2829. So let's see if it backs up. Yep, see right there. Mu is 1.713, and down here it says sigma is 1.282. So that's the first parts of this problem done. Okay, now it wants us to treat these simulations and do those problems, right? So it says, okay, you found the mu and the sigma. Those are the theoretical mean and standard deviation. Theoretical because in theory you have the entire population accounted for. That's why they're mu and sigma. But now you want to find the x bar and the s for each of these situations, for the 25 games and the 50 games. So I'm going to go back to my calculator. I'm going to press Stat. I'm going to press Edit. I'm going to go over to L3. I'm going to type in my theoretical distribution. So I'm going to go down the column. So 0, 2, 1, 0, 3. Now I move over to the next column. 2, 1, 1, 3, 1. Now the next column. 3, 3, 0, 1, 2, and so on. And then 4 2s in a row. Got to do that correctly. Just be very careful when you're typing, because if you type any of this wrong, you're going to be in trouble. Now, I've done something wrong because it's saying that this blank is on the 25th line, but there's no way it's on the 25th line because I have 25 numbers. That means that I missed something somewhere. So now I've got to go back to the top and double check. You have to be just so extra crispy careful when you put these in. All right, so 0, 2, 1, 0, 3. 2, 1, 1, 3, 1. Another way you can kind of see this is that that 1 is correct because it's the 10th number. See how it says L310? So it's telling you the 10th number, which is 1. So if I go to the 11th number, 12th, 13th, 14th, 15th, that should be a 2, and it is, right? And then I need another 2. 1, 2, 3. There it is. I'm missing. Number 19 should not be a 5. Number 20 should be a 5. So if you make this mistake, what you want to do is insert another number 2, right? So if you hit above the delete key, second, hit the blue button, and then the delete key, it'll insert a number for you. And then you can tell it what you want it to insert. I want to insert a 2. And I press 2, enter. And there we have enough 2s. So number 20 is a 5. There's 19, 18, 17, 16, and number 15 was a 2. So there I have all 5 of my 2s there. And then everything else should be good. I just used the down arrow and got down here, and I can see it's the 26th, so it's waiting for the 26th entry, which is appropriate because there should be 25 entries in there. So now I'm going to go to Stat, go to Calculate, tell it to do one variable stats, but this time I don't want L1, I actually want L3, which is my raw data from that simulation. Then I go down to the clear out the frequency list. You don't have a frequency list because this is not a table. This is just one long column of data. And then I'm going to go down to Calculate and press Enter. And there I can see my X bar, which really is X bar this time because this is from a sample of 25 games, is 1.68. And my standard deviation is now 1.215. I should be using S here because this is a sample, not sigma because this is not a population. So X bar is 1.68 and S is 1.215. So let me double check that. Oh, see right there. X bar 1.68. S down here at the bottom is 1.215. So we did it correctly. And then all you do is just repeat it for 50. So you take your calculator, you go back to Stat, you go back to Edit, and you go over to the 4th row, and then you just type in all the other numbers. So you type in those 50 numbers instead. So I'm not going to make you watch all of that, but I'll just start the typing with the first couple so you can see it. And then I'm going to pause and I'll be right back. There, I have all 50 numbers in, and I made very sure as I was typing that the bottom number here, like the 5th number, the 10th number, the 15th, and so on, was matching as I was typing, just to be sure, because it's so many numbers to type in. Then we go to Stat, go to Calculate, one variable. This time I'm going to do L4, second number 4, and then go down to Calculate and press Enter. And I find that I have 1.76 and 1.302. Which is right here, 1.76 and 1.302. As for the last bit of this question, if you look back at your mu and your sigma, particularly the mu, you can see that mu was 1.713 and sigma was 1.282. And then when you look at 25, we're at 1.68 for our X bar. But when we do 50, it's 1.76. And so what you're seeing is that the larger the sample you take, for example, 50 games, the closer it is to what the population value was. In other words, the more you play or the more random experiments that you grab, the more that the distribution of those random experiments is going to look like what the population distribution was. So that's discussed in the notes as kind of a probability argument as well. So that's why casinos want to keep you there longer, et cetera, et cetera. I will let you ponder which of the 3 answers that is, but Basically, we're saying the more that you perform these experiments, the more the sample values of X bar and S are going to be like your population values. In particular, X bar is going to be like your population value for mu. All right, I hope that helps with that problem. I'll see you back here for more tutorials.